Okay. So I misspoke a couple times in the last video. I hate that. First of all, I kept saying 16-bit when I was here. What I meant to say was it's for what I was trying to say 64-bit. Anyway, maybe I was saying 16-byte. No, I was saying 16-bit. Basically, there's a 64-bit table is twice as big, with the entries twice as big. And what I did is I used the same table for 32 and 64 by just leaving blank entries every other entry in the 32. So the 32 has 0 entries every other entries, but when it's switched to 64, those are part of the entry. Anyway, you know what I mean. So yeah, I hate that. Demons sometimes that made me screw this up right when I was here. I said fixed. That's the opposite word I should have said. Basically, there's a DS and a CS for pointing to the address this module is loaded. 7C. DS and CS are set to 7C00. Maybe 1. Anyway, that's so that the offsets of the global variables are correct in this module. Then they get patched. But anyway, you know, it's nice when you're possessed by a spirit and it makes you more intelligent. It sucks when a demon makes a mockery of you. That happens. It's part of this realm. This realm, it's happened horribly. You feel violated. You know, you fucking made me. You humiliated me. Anyway, that happens. God said it was a demon. It wasn't him. I'm not sure. I guess so. Anyway, I guess you have to take the good with the bad. If you get super smart, and sometimes you have to get. Sometimes God just does it. I'm telling you. I'm just forewarning you. Just forewarning you. It happens. He will, and you'll feel like he cut your heart out or something. I don't know. Just feel numb. Anyway, so the boot sector. What I was trying to get at is, in 64-bit mode, these are 0, and I don't think the limits don't matter either. So I was trying to say that, but these, I was right on the spot where it was the. Okay, enough talking. This is not 0. It's the boot sector, CS and DS. Okay, enough of that. I want to talk about my assembler. So my assembler is I try for minimum lines of code. There's only a little bit of 16-bit code that it has to handle. It has to handle the boot sectors. These are 16-bit. And it has to handle the startup when it's changing to 64-bit. So it's only there is absolutely no need for any other 16-bit code. No need for any other 16-bit code. So you know what I did? I cut corners. I did not do segmentation. You have to hand code a segment jump. I also cut corners because there's a modder SIB table, and I only used the 32-bit, not the 64-bit. In 16-bit mode, I use 32-bit addressing, so I use the 67 prefix. So my 16-bit code is using 32-bit addressing modes. It doesn't matter. You only need a couple. It's not worth making the assembler big. What are you doing, Dave? What are you doing 16-bit code? You're making another operating system, aren't you? Anyway, so I wanted to talk about how my assembler works. First of all, it initializes. First, let's talk about lexing. The lexical analyzer is a function. It says, let's say we're starting right here, where my cursor is. It says, okay, there's a keyword if, there's a that's what it returns. Then it says there's a parenthesis, there's a identifier LX, there's an operator dereference minus greater, there's or arrow, I don't know what you call it. There's a identifier token, there's an operator equal. So that's what the Lex does, is it starts doing some of that work. And the Lex also strips out comments, and it puts together strings, and it figures out constants and integers. Anyway, so to do the assembler, I already had the Lex and the expression evaluator from my compiler, and so to do my assembler, I mashed everything together in Get Fusion. My assembler is based on the C compiler that I wrote. So it uses C expressions, and anyway, so when it initializes, it loads this opcode table. It loads. I had to hand type all these, and I skipped. I didn't do some. I did shortcuts because you don't need certain instructions, and I wanted my assembler simple and stuff. It wasn't worth it. So there's an interesting thing to note here. Take the move instruction. You have special cases for AX. Then you have there's sometimes you get 3 or 4 instructions that are valid. What you have to do is find the shortest. So in my assembler, I have a mask for argument type. So there's these are addressing modes: relative 30, relative 8, relative 16, relative 32, immediate, unsigned, signed, register, memory with offset. I don't do those offsets. I told you it's not worth it. There's only a little bit of 16-bit code I have to worry about. There's no other way you can. There's not. Users are not supposed to be running 16-bit code. There's just no reason for it. Anyway, so these are bit masks. Remember it's 64-bit, so it's really nice having 64 bits when it's just perfect. Anyway, so it uses process of elimination. First, it says, okay, is it a 64-bit instruction? Okay, set the mask. Is it a 32-bit? Set the mask. Is it a 16-bit? Set the mask. Then it starts eliminating. Is the current segment 64-bit? Then eliminate some. Did they specify 2 registers? Eliminate some. Is there an immediate or an offset present? Is there an immediate or offset present? Eliminate some. So it whittles away. Then you end up with 1 or 2 left over, and then it uses the smallest. It computes each one and uses the smallest instruction, and that's how it works. Now, there's a tricky part. Okay, a couple tricky parts. For absolute addresses, if you have an expression and it's an absolute address, then that's an absolute address. If you have 2 absolute addresses, the user is subtracting them. You don't add absolute addresses, you only subtract them. If you have 3, that's an absolute address. It's a difference plus an absolute address. If you have 4, that's 2 subtracted. You never add absolute addresses. So this is something I get away with because I'm special. Somebody might call this defective, but we don't. We are building a product where cutting corners is why it has value, because it's simple, and we're making the Commodore 64, not a NASA computer. Anyway, so I call it melodramatic coding. Some people get melodramatic, and do you realize how much extra code it would take to get around this? It's stupid. It's melodramatic. Anyway, So when I do when I have an expression, let's say one of the hardest parts of the assembler is an expression evaluator. In assembly, you can get forward references, and okay, let's say we have this expression. So it has. I borrow my compiler, my C compiler, and I compile a C expression. Let's say one of these is. These are all constants, but let's say one of them is not a constant. Let's say this is. Let's say this is a forward reference right here. It's fixed. It's not, but let's say it is. Then you would say, what I do is I make an entry in my symbol table, and I say, okay, I make a hash entry, and then I make a spot for what its value is going to be. Then in my expression, I say, let's say this is at 1,000, and this is at 1,008. Then what I say is take star 1,008 plus constant times 8. So I make a little, I convert it, I actually compile it to an expression. I say move RAX, well, I'm just saying 1008, move RAX, add RAX 123. Okay, so I make some code and I set it aside for when we have this resolved. So at the end, I check and I say, okay, have all the expressions been resolved? And the answer is yes. And so then I call this code and it executes that and it resolves that value. And that's how we get the value that we propagate back to where it was used. If it's an import, let's say it's not resolved, we probably want to import it. So that's how it works.